Hey there, class. I hope you're having a great day so far. I'm really sorry I'm not there with you in person, but I know you're in great hands with your substitute. And I'll be back tomorrow if you need anything or have any questions for me before our quarter ends. Now, with that being said, there are a couple things I wanted to explain to you about today, just to make sure there's no confusion and we don't forget anything important. So today, your first order of business is to turn your binder into the box by the window in our classroom. I've left a box there, it's labeled. You're just gonna put your binder right in that box for me to pick up when I'm back and grade over the weekend. So please, please, please don't forget to leave your binder in that box. After you drop your binder off, then you are going to watch the rest of this video, because in the rest of this video, I have included our video lesson for today. So the same lesson I was going to teach if I was in person, I've put into a video format, and your substitute has the notes packets that we normally fill out together in class. Your job today is to watch the video, and as I go through the notes, you are going to fill yours out with me. Once you're done, then you can use your extra time to get started on your homework or any final NTIs that you might owe me. If you have any questions about that, please let me know. We will be going over this homework when we come back on Monday, so please make sure you have it. And if you have any questions, the Math Center is a great place to go. Or like I said, I'll be back tomorrow on Friday, so I can help you then as well. I hope you have a wonderful day. I know you're going to be great for the substitute, and I can't wait to hear how things go when I come back. I'll see you later, guys. Today we're going to continue our previous discussion about linear equations and slope-intercept form. Before we dig a little deeper into this topic, let's just refresh our memories about what we've previously learned. When we talk about slope-intercept form of a linear equation, that's one of the ways we can represent a line. And it's written as y equals mx plus b. Now, in our last class, we discussed how m is going to always represent the slope of the line. Now, that slope describes the steepness of the line, how steep or flat it might be. And b is always going to represent our y-intercept. Now, the y-intercept is the spot on the graph where the line crosses over the y-axis. So when we're working with linear equations in slope-intercept form, the slope and the y-intercept are the two most important pieces of information we need. They tell us exactly how we are going to graph our line. So today we're going to dig a little deeper into this topic, and we are going to work with problems in which we're being asked to find the equation of the line, but they're only giving us the slope and one of the points. So to solve a problem like this, the first thing we need to do is identify the slope and the point that we're working with. So in this example, our slope is -2. They gave us that information. We didn't have to do anything to solve it, but read our problem carefully. And then they give us a point, -4, 9. Now, while this is not the y-intercept, it is a point on the line. The problem tells us that the line passes through that point. Now, if it's a point on the line, that means we could substitute the x and y values of this point into the equation of the line when it's in slope-intercept form, and it will result in a true solution or a true equation. So we can use this to kind of work backwards and find that equation of the line. So step number 2, use the slope and the point to find the y-intercept. So to do this, we're going to start by thinking about what information we do have. We know that slope-intercept can be used to represent a line. We know that we have the slope -2. So I'm going to replace m with -2. And the other piece of information they've given us is the point that the line passes through. Now we can use these points as our x, -4, and y, 9, in our equation. That leaves us with the variable b as the only unknown left. And that allows us to solve for b and find the y-intercept. So just to recap, I started with my slope-intercept form equation, and now I've plugged in my slope and the x and y values from the point the line passes through. Now I just need to solve for b. So I'm going to simplify this. 9 equals 8 plus b. Then I subtract 8 from both sides. That isolates my variable b, and 9 minus 8 is 1. So now I know what my y-intercept is. The y-intercept is 1. So the last step is we put the pieces of information together and get our final answer. So we're going to use the slope and the y-intercept to write our equation in slope-intercept form. So that will be y equals -2, that was the slope they gave us, x, plus the y-intercept we found, which is 1. So our final equation is y equals -2x plus 1. Now let's try one together. I want you to pause the video and try it first, then play it and use my explanation to check your work. So at this point, you've hopefully already solved the problem as best you can using our last example. And now we're going to go over it together. So in this problem, they're asking us to write the equation in slope-intercept form of a line that has a slope of m equals 1/2 and passes through the point -10, 3. So the first thing I'm going to do is identify the information they've given me. They've given me my slope, which is 1/2, and they've told me that the point the line passes through is -10, 3. So I can use that point as my x and y values in my slope-intercept form to find the y-intercept. So I'm going to start by writing out my slope-intercept form. This is kind of like my template I'm always going to start with, just so I don't forget any pieces. Then I'm going to substitute y with 3. M is 1/2. So I'm going to replace m with 1/2. X is -10. And b, we don't know. So that's what we are solving for, and that's our y-intercept. Now that I've written out my equation and plugged in the information that I do have, I'm going to simplify this to isolate my variable, and that will tell me what my y-intercept is. So I'm going to simplify first. 1/2 times -10 is -5 plus b, and then we'll add 5 to both sides. 3 plus 5 is 8. B equals 8. So now that we have our y-intercept and our slope, we can write our final answer. So the slope-intercept form of this line would be y equals 1/2 x plus 8. Now let's do a couple more examples before we move on. In this first example, number 1, we have our point 3, 1, and our slope, which is m, and that's 4/3. So I'm going to start by writing out my equation, y equals mx plus b, and I'm going to plug in the information I have. I know y is 1, m is 4/3, x is 3, and b is what we're solving for. So that's going to stay a variable. That's going to stay b. Now let's simplify this. 1 equals 4 plus b. I'm going to subtract 4 from both sides. Negative 3 equals b. So my final equation in slope-intercept form is y equals 4/3 x minus 3. Notice how because it was negative 3, instead of y equals mx plus b, that negative sign turns it into y equals 4/3 x minus 3. Next, we're going to work with a line that passes through the points 5, negative 3, and has a slope of negative 1/5. So to start, I'm going to write my equation, y equals mx plus b, and I'm going to plug in the information they've given me. So y is negative 3, m is negative 1/5, x is 5, and b is b. That's going to stay the variable b. So now I'm going to simplify this. Negative 3 equals negative 1 plus b. I'm going to add 1 to both sides. And negative 2 equals b. So our final slope-intercept form equation is y equals negative 1/5 x minus 2. All right, for number 3, we're going to first label our information. We have x, y, and our slope. Now I'm going to write my equation, y equals mx plus b, and I'm going to plug in the information they've given me. So y is negative 3, m is 8, so I'm going to replace m with 8, x is negative 3, and we're going to leave the variable b because we want to find our y-intercept. Now let's simplify this. We get negative 3 equals negative 24 plus b. I'm going to add 24 to both sides, and we get 21 equals b. So our final equation, we're going to put our information together. We have our slope and our y-intercept. So y equals 8x plus 21. All right, and another example this time, let's label our pieces as x and y, negative 12 and 4, and then our slope is negative 1/6. We'll write our equation, y equals mx plus b, and we'll plug in our information. Y is 4, m is negative 1/6, x is negative 12, and the y-intercept is b. Now that I've rewritten all of this, let's simplify it. 4 equals negative 1/6 times negative 12 is the same as dividing negative 12 by negative 6. So that's positive 2 plus b. We'll subtract 2 from both sides. 2 equals b. So now I have my information, my slope and my y-intercept. So y equals negative 1/6 x plus 2. Our next section, we are going to add one more step to our process because in these examples, they're not giving us the slope and a point like they were before. Instead, they're just giving us 2 points that the line passes through. So that means we have to find the slope ourselves. Now, as a reminder, our slope equation is y2 minus y1 over x2 minus x1. Now, the good news is to find the slope, all you need are 2 points. Now, they've told us that the line passes through the points -1, -2, so that's x1 and y1, and then points 3, 4, so x2 and y2. Now I can plug that information into my equation for the slope to find the slope of this particular line. So m equals y2 minus y1, so 4 minus -2. And then x2 minus x1, so 3 minus -1. Now when I simplify, 4 minus -2 is 6. 3 plus 1 is 4. That simplifies to 3 over 2, and that will be our slope. Now that we have the slope, we can think back to what we were doing before. We can use the slope and one of our points to find the y-intercept. The good news is, because they've given us 2 points, we have options. Now, normally, you would not have to solve both of them, but for this example, we're going to try each point to see if they both work and give us the same y-intercept. So first, we're going to use the point -1, -2. So my equation is y equals mx plus b. We know that our x will be -1, our y will be -2, and our slope is 3 over 2. So I'm going to plug that in now. Y is -2, m is 3 over 2, x is -1, and b will stay the letter b. Now when I simplify this, I get -2 equals -3/2 plus b. Then I'm going to add 3/2 to both sides. That way I can isolate my variable. But I have a whole number and a fraction. So I'm going to come over here and rewrite this as -2, and I'm going to turn this into a fraction with a denominator of 2, so it matches and has a common denominator as the fraction I'm trying to add. So if I want to turn this -2 into a fraction with 2 as the denominator, I'm going to multiply both the top and the bottom by 2. So it becomes -4 over 2. And then when I add -4 over 2 plus 3 over 2, we get -1/2. So -1/2 equals b. Now let's test out the other equation. So in this one, we have the point 3, 4. So we're going to use 3 as our x and 4 as our y. And our slope, because this is the same line, our slope is the same, 3 over 2. Now my equation, once again, I'm going to write it down, y equals mx plus b. And now I'm going to plug in the information we have. So y is 4, m is 3 over 2, x is 3, and b is b. Now I'm going to simplify, and I get 4 equals 9 over 2 plus b. And then to isolate b, I'm going to have to subtract -9/2 from 4. But once again, I'm subtracting a fraction from a whole number. So I'm going to take 4, and I want to turn it into a fraction with a denominator of 2. Now, if it's 4 over 1, that means I need to turn it into an equivalent fraction, which would be 8 over 2. So we have 8 over 2 minus 9 over 2, and we end up with -1/2. So negative 1 over 2 equals b. And notice we've got the same thing for both points. So that proves that we can use either point, if they've given us two, to find the y-intercept. Since they're on the same line, they will represent the same y-intercept. Now our last step is we write the equation. So we have y equals, our slope is 3/2. So 3/2 x, and then our y-intercept is negative 1/2, so that's minus 1 over 2. And that would be my final answer. So this question is asking us to write the equation in slope-intercept form for a line passing through the points 5, 4, and negative 1, 6. So I'm going to use 5, 4 as x1 and y1, and I'm going to use negative 1, 6 as x2 and y2. Now that I've labeled those, I'm going to start this process by finding the slope of the line. So slope is y2 minus y1 over x2 minus x1. So I'll plug in the numbers that we've been given with the points that the line is passing through, and that is y2, which is 6, minus y1, which is 4. And then x2, which is negative 1, minus x1, which is 5. Now that I have written out my problem, I'm going to simplify it. So 6 minus 4 is 2. Negative 1 minus 5 is negative 6. So our slope, when I simplify this, is negative 1/3. Now that I have my slope, I can find my y-intercept using our equation y equals mx plus b. Now, I have to pick one of my points to be able to find my y-intercept, so I am going to use the point negative 1, 6. And this will be my x and my y when I try and find my y-intercept. Now that I've identified that information and I know my slope is negative 1/3, I'm going to plug all of that into our equation. So 6 equals negative 1/3 times negative 1 plus b. Now when I simplify it, I get 6 equals positive 1/3 plus b, and then we'll subtract 1/3 from both sides. Now, 6, I need to rewrite that so I can subtract the fraction. So 6 times 3 is 18. So we could rewrite this as 18 over 3. So 18 over 3 minus 1 over 3 is 17 over 3. So that will be our y-intercept, 17 over 3. Our final answer and our final equation is y equals negative 1/3 x plus 17 over 3. Now in your packet, let's do example number 1. Here we have 2, 1 and 4, negative 5. So I'm going to start by labeling my points. This will be x1 and y1. And this will be x2, y2. So step number 1, I'm going to find the slope. That's y2 minus y1 over x2 minus x1. So y2 minus y1 is negative 5 minus 1, and x2 minus x1, which is 4 minus 2. Negative 5 minus 1 is negative 6. 4 minus 2 is 2. So our slope for this problem is negative 3. Now that I have my slope, I can find my y-intercept. So I'm going to pick one of my points. I'm going to use 2, 1, 2.21, and I'm going to use this as my x and my y to find my y-intercept. So y equals mx plus b. Y is 1. M is -3. That's what we just solved in our last step. X is 2 from the point they gave us, and b will stay b. Now when I multiply -3 times 2, I get -6, and I add 6 to both sides to get b alone. So 7 equals b. Now we have our slope and our y-intercept. So our final equation is y equals -3x plus 7. Let's do another one together. This is number 2 in your packet. So first I'm going to label my points. We have x1, y1, x2, y2. My slope is y2 minus y1 over x2 minus x1. Let's plug in our points. So we're going to start with y2 minus y1. So that will be 3 minus -5. Then we'll do x2 minus x1, which is -4 minus 0. 3 minus -5 is 8 over -4. So our slope is -2. Now we can use this to find our y-intercept. Let's pick a point. We'll use 0, -5, and this will be my x and my y. So y equals mx plus b. Y is -5, m is -2, x is 0, and we're going to leave our variable to solve for b. So -5 equals 0 plus b, so -5 equals b. Now we have our slope and our intercept. That's all we need for slope-intercept form. So y equals -2x minus 5. All right, I want you to try this one on your own, then press play and check your work. Now that you have hopefully done this on your own, let's see if your answer matches mine. I'm going to start by labeling x1, y1, x2, y2, and then I'm going to use my slope equation, y2 minus y1 over x2 minus x1. We'll start with the y's. y2 minus y1 is -4 minus 5. And then the x's, x2 minus x1 is 1 minus 3. Now, -4 minus 5 is -9. 1 minus 3 is -2. So our slope here, when the negatives cancel out, will be 9 over 2. Now, if we're graphing this, this would be a rise of 9 and a run of 2. Now that we've found that slope, let's use it to find our y-intercept. So we're going to use points 1, -4. And I am going to plug that and one of my points, and my slope, I should say, into y equals mx plus b. So this will be y, this will be x. Y is -4 equals 9/2 times 1 plus b. So -4 equals 9/2 plus b. And we have to subtract 9/2 from b. So that means I'm going to turn -4 into -8 over 2. -8 over 2 minus 9 over 2 is negative 17 over 2 equals b. So I know it might look a little wonky, but when graphing linear equations, these very well could be valid answers. So in this problem, our equation is y equals 9/2 x minus 17 over 2. For number 4, in your packet, let's label our points. We've got x1 and y1, x2, y2. Now that we have our 2 points, we can find our slope. Our slope will be y2. Our slope will be y2 minus y1, so 5 minus 3, and x2 minus x1, 0 minus 3. When we simplify, we get m equals 5 minus 3 is 2, 0 minus 3 is negative 3, so m equals negative 2/3. Now for our y-intercept, I'm going to use the point 0, 5 and my slope-intercept form to find the y-intercept. So 0 will be x, 5 will be y. When I plug those in, I get 5 equals negative 2/3 times 0 plus b. 5 equals b. So our final equation is y equals negative 2/3 x plus 5. All right, so we have 2 examples left in our notes packet. Let's start with example number 5 by labeling x1, y1, x2, y2. Then we're going to find our slope, which is y2 minus y1 over x2 minus x1. So y2 minus y1 is negative 1 minus 4. x2 minus x1 is 4 minus negative 5. When we simplify, we get negative 5 over 4 plus 5 is 9. So our slope is negative 5/9. Now let's find our y-intercept. I'm going to use the points 4, negative 1. And I'm going to plug that with our slope into y equals mx plus b, our slope-intercept form. So 4 will be x, negative 1 is y. So I'm going to rewrite this as negative 1 equals negative 5/9 times 4 plus b. Now I can simplify this a little bit. Negative 1 equals negative 20 over 9 plus b. Now we're going to add 20 over 9 to both sides. And we get b alone on the right. But here, we're not really adding 20 over 9 to negative 1. We have to make this into a fraction with a common denominator. So this would be negative 9 over 9. And then when we add that to 20 over 9, negative 9 plus 20 is 11. So this would be 11 over 9. So our final equation is y equals negative 5/9 x plus 11 over 9. Now in our last example, I want you to do this one on your own. And I am going to check your answers when I return. So use the previous examples we just did and I want you to figure out what would be the slope-intercept equation for a line passing through the points 3, 1, and -2, 3. In our next and last example, we are going to use a linear equation to represent a real-life situation. Amari is taking the subway to his summer job and then back home every day. The cost of riding the subway is the same every day in both directions. We are being asked to write an equation to represent the balance that is on his fare card at any given time. So they've given us some information, but not necessarily enough to make predictions in the way they've given it to us. So we are going to put it into a linear equation. Now, after each ride, the balance on Amari's fare card decreases by the cost of the ride. So because that decrease is a constant rate of change, we can use a linear equation such as y equals mx plus b, our slope-intercept form, to describe the relationship between the number of rides that he has taken. So x will represent how many rides he has taken. And then we can use that to figure out what the balance on his fare card will be after those rides. So let's say, for example, we figure out the rides are $2 each. Well, if we do $2 times the number of rides, we can figure out how much he's paying and then work from there to figure out the balance. So we're going to put this in a handy-dandy equation, but to do that, we need some points on the graph, some points that are on the line that we're talking about. So we have to represent our points using the x and the y values the situation is presenting. So if x is the number of rides, this is telling us that on Monday, his balance is $45.15 in the morning. So that's before he has taken his afternoon ride. So that means when the number of rides is 1, his balance is $45.15. So this would be Monday. Now, when we look at the other information they've given us, they've told us that on Thursday morning, his balance is $28.65. But we need to figure out how many rides that is. So on Monday, he took 2 rides. On Tuesday, he took 2 rides because he has to go to work and then back home. On Wednesday, he took 2 rides. And on Thursday, since this is the AM, he's only taken his morning ride. So that's 1. That means he has taken 7 rides by the point at which we looked at this balance here. So when he's taken 7 rides, the balance is $28.65. Now that we've identified our points, we can use our strategies we've been practicing in this lesson to turn this into a linear equation. So the first thing we need to do is find our slope. So I'm going to start by subtracting the y values, 28.65 minus 45.15, and then my x values, 7 minus 1. Now, once I do that, we end up with 28.65 minus 45.15, and we get negative 16.5 over 7 minus 1 is 6. So if we divide negative 16.5 divided by 6, we get negative 2.75. So there's our slope. And now, to find our y-intercept, we are going to plug this information into our equation. So let's use 45.15 for y. Negative 2.75 is our slope. X is 1. And B will be our y-intercept. Now, B will represent the balance when the number of rides is 0. That's what makes it the y-intercept, and why it can tell us what the balance on the fare card will be. So I'm going to start by adding 2.75 to both sides. You might be saying, wait, she didn't multiply. But that's because I'm multiplying by 1. So I know that that's just going to stay negative 2.75. So I went ahead and added it. 45.15 plus 2.75, that's 47.9 will equal B. So our final balance is $47.90. So if we're going to write an equation to represent the situation, we would write y equals negative 2.75x plus 47.9. Now this means that each ticket, each ride, costs $2.75. That's why each time we take a ride, it decreases by that amount. That's what makes it our slope. So now there's one more problem on your packet. I want you to try this one on your own using your resources available, your notes, your examples in this video to answer this the best you can. And that brings us to the end of our lesson. So with that, I hope you have a great rest of your day. Make sure to check Veracross for your homework. And I will see you on Monday. Bye, guys.